All right, so now we're going to talk about perfect cubes. So a perfect cube can be a number written with an exponent of 3. And it represents, or it can represent, the volume of a cube. And we can call it cubing a number. So if we look at this cube that we have on our paper in front of us, we see that it has a side, and it has 1, 2, 3 squares. So we can say that each side of this cube has a length of 3. Okay, so then we're going to write our side length is 3. And then volume, if we recall, is length times width times height. And in other words, we can write that as 3 multiplied by 3 multiplied by 3, which gives us 27. Now, another way we can write this, because of perfect cubes, is we can write it as 3 to the power of 3, which gives us 27, and 27 is our perfect cube. All right, so then we have a list of perfect cubes, and I would know maybe up to 125. And I want you to just note that the way that we're getting these perfect cubes is by multiplying a number by itself 3 times. So for example, for 1, we have 1 multiplied by 1 multiplied by 1, which gives us 1. For 8, we're having 2 multiplied by 2 multiplied by 2, which gives us 8. And then for 3, like we just did up in our example there, 3 multiplied by 3 multiplied by 3, which gives us 27, so on and so forth. Okay? So then for the cube root, which is the next thing there on our notes, that would be the inverse of cubing a number. Okay? So the same as we found the square root in the perfect squares example, we're going to find the cube root by taking the cube root of what we found. So we can use this to find the side length of a cube of the when given the volume, and then the notation for cube root is the little root sign with a 3 next to the root symbol. Okay, so if you look at this example, the cube root of 27 equals 3. And let's just take a moment to note that this is different from the square root. If I just gave you the root symbol with 16 in there, it is implied that we have a square root here. And that we know that that number is called the index. And we remember that from the previous example that we did. So in our example here, we have the index we know is 3, so we know that that means that this is the cube root. And then so if we just look down at the last little piece here, we have the 3, which is the index, as I just mentioned. The 27 would be called the radicand, and the entire thing, once again, would be called the radical.